My name is Rafaela Ribeiro and I study Physics Engineering at Instituto Técnico. I'm here to talk about my master thesis project, Spintronic antennas for energy harvesting from power lines. This project is supervised by Professor Susana Freitas and Professor Rita Macedo from Engenharia. The emergence of several applications such as sensor networks and biomedical implants requires advances in wireless technologies and the need of a new generation of low-power devices. These type of applications normally needs an integrated power supply, which normally reduces the network performance. Radio frequency energy harvesting from ambient sources is a promised solution to power future wireless networks and to develop self-powered sensors based on energy harvesting, enabling long-term and maintenance-free sensing systems. Although different methods of energy harvesting are available, such as vibration, light, and thermal energy extraction, wireless energy harvesting is one of the most promising solutions due to the simplicity of implementation and availability. For sensing applications, the magneto-resistive sensors are widely used for field detection, taking advantage of the high magnetic field sensitivity, small dimensions, reduced costs, and integration capability. The main goal of these projects is to optimize and fabricate energy harvest units. These units consist in a resonant antenna capable of capturing an external radio frequency field, integrated in series with a magneto-resistive sensor, which will be powered by the current induced in the antenna. This device consists in three main components. The first component is a driving external source to power the device, for example, a radio frequency external electromagnetic source. This source can be produced by a current-carrying wire, as stated by Ampere's law, where the current in a closed loop produces a magnetic field. The second component is a resonant antenna, responsible for capturing a surrounding radio frequency field. This antenna consists in a microfabricated metallic loop. By Faraday's law of induction, the external radio frequency source induces an electromotive force in the antenna, generating an AC current. One way to maximize the current induced in the antenna is by integrating a magnetic core. Soft magnetic materials are the usual choice for this type of applications, since they concentrate and guide the magnetic flux. Furthermore, they are characterized by their high permeability and minimal hysteresis. The hysteresis energy loss is given by the area enclosed by the magnetization loop, where it shows how the magnetization changes in the presence of a magnetic field. Since hard magnetic materials have a larger area compared to soft magnetic materials, soft magnets are the ideal choice for magnetic cores. The final component, and a very important one, is the magneto-resistive sensor. This is the core of the device since it is capable of sensing external magnetic fields. A magneto-resistive sensor behavior is characterized by its transfer curve, which represents the output resistance of the sensor dependence on the magnetic field signal. For an ideal magnetic sensor, this curve is linear and it is hysteresis-free within the field operating range. The curve has two stable resistance plateaus and a linear reversal path between them. Other important feature is the field sensitivity of the sensor. This represents how reactive a sensor is to a field variation. My work during this project will be dedicated to the study and optimization of the microfabricated antenna parameters, such as size, geometry, and materials, aiming at maximization of the current in the magneto-resistive sensor for a better device performance. The final device will be microfabricated and finally a full characterization will be developed. In particular, the efficiency of the harvesting energy, the device sensitivity and power consumption will be studied. Thank you for watching.